Hello. Okay, so good morning, everyone. Welcome back to the class after 2 weeks. So today we are going to talk about network programming. As I said, 2 weeks ago, we finished multi-thread. The first part of this course, which is concurrent programming. And now we are going to the networking programming, okay? And so for the network programming, the first time we are going to talk about some different method for data transport, okay? So this lecture, we are going to talk about TCP. I don't know if you've heard about this, okay? We are going to talk about some networking basics first, and also about socket. It's a very important concept for network programming, okay? And then the different thing compared with concurrent programming is that from now on, we will always, I would say usually, we will usually have two programs, okay? One is for client, another one is for server, okay? So for any program we are doing programming, now we will have two files. One code file is for client and another one is for server. Okay, so today we are going to talk about programming TCP clients and servers. Okay, after that, we're going to talk about combining multi-thread programming with network programming. Okay, multi-threaded TCP servers. And for this URL library package, we're not going to talk about today. Okay, we're going to talk about this when we meet the application. Okay, so this will not be talked today. And also, a lot of students have asked about the midterm exam. Actually, not midterm exam, it's a quiz, okay? So it will not be that difficult as a general midterm exam as you think, okay? So I have put a vote in the WhatsApp group. And you can vote the date you prefer, okay? Because I think some of you might have a busy weeks during this period. Maybe you will have other midterm during this period. So I'll give you some flexible schedule for this quiz, okay? Okay, so let's then go ahead to the main content today. Okay, sorry. I'm a bit sick, so you can hear from my voice that it's not very good. But doesn't matter, okay? So let's talk about the networking basics, okay? Some terminologies on that, some basic concept. So you know that we have a lot of different devices, okay? So you might have like devices from Apple, Huawei, or Microsoft, right? So how they communicate with each other. So there is a standard Internet Protocol suite, okay? It's called IP. I think you are very familiar with this word IP because I think you know about this IP address, right? Uh, Wait, let me find a pen. Okay, so the main point here is that we have a standard one, okay? So this standard allows communication between different devices, okay, from different manufacturers to work together because different brand, they have different operating system, right? And different devices, different hardwares. So how they communicate with each other is based on these IP standards, okay? So for this standard model, we have 4 layers. And we are mainly going to focus on the layer 4 to 2, okay? The first one, physical layer, usually it's about, the electronic guys or the wireless communication guys will work on it. But we are computer science and computing guys, right? So we will only focus on these 3 layers here, which is network layer, transport layer, and application layer. Okay. So application layer, yeah, it's just like the application. It's like the services provided for the users, like the HTTP, the website, right? And also like FTP for file transfer, okay? And then the most important layer that we are going to talk about in this course is this transport layer, okay? So this is about how the data will be transported to different devices. Okay, and we have TCP and UDP that we are going to talk about later. Okay, and then we also have network layer. So this is related to the route of the data, how it transfer. Okay, and like the example is the IP. Okay, so here is a word called encapsulation. What does it mean? It means one layer uses the service provided by the layer below. So the application layer is based on the service of the transport layer. And the transport layer is based on the services provided by the network layer. Okay, it's very intuitive. So it's like because as I said, network layer provided the route for data transmission, right? So once you have the route, you can transfer the data, you can transport the data. Okay, so when we are going to transport data, it's based on the network, the route that defined by IP. Okay, and after you've transported the data, you'll be able to do this application part, application layer. Okay, so this is called encapsulation. Okay, then let's talk about this IP, Internet Protocol. So of course, you are very familiar with this word IP, especially for this IP address, right? But IP is a wider concept. So it is like something regulate how the network work together, okay? So it regulates the route of the data transmission and also the address of the host in a network, okay? So it regulates 2 things. One is address, another is the route, okay? So IP is actually similar with like a mailing company, okay? And then it defines some route to deliver your things, your parcels, okay? And of course, you have some mailbox, at your home address, right? So this is like the IP address. So this IP company just deliver things on your IP address based on their workers. Okay, so the workers, or we say the courier or deliver guys, it's like the TCP or UDP. Okay, so the transport layer is more like the deliver guy. Okay, so we have two types. I mean, we have more types, but we are basically talking about TCP and UDP in our class. Okay, and in this internet protocol, the data are usually sent in independent packets, or we say datagrams. So what is packets? So it's like just a part of data, a pack of data. Okay. So usually you are not able to send all the data in one time. You are divided into different packs and then send it and then reorder it. Okay. It's just like sometimes you have you buy some very huge items from the internet and then they will deliver it to you by different packages, right? So the same as internet protocol. The data are also sent in independent packets. And so for each packet, we will have some data for IP header. Okay, we'll have some extra data for IP header. So this provides you the information of the original address, the target address, and some other things. Okay, just some IP related information. So it will take like 20 to 60 bytes, some extra data. And the rest is the data that you want transport. And the packet size, there's a limitation. Okay, so the physical limitation is this number. Okay, 65,535. I think for your, I mean, you are in this computer science major, so I think you are very familiar with this number. And then one thing you need to know is that IP packets, although the size limitation is like 65,000, okay? But usually we will pack it into much smaller packets, okay? Usually 8 kilobytes or less. Why? This is because of like the method of the internet that we are using might have some other limitation of the maximum data it can transmit one time, okay? So for example, the Ethernet 以太网, okay? Let me give you an example. Ethernet,以太网. So the maximum of this Ethernet data is like 1,500 bytes. 1,500 bytes, okay? Then if you give data packets for 65,000 bytes, then you need to divide this data into much more smaller packets again, okay? So you need to divide this data for 40 times again to match with the maximum data transmission for this internet, right? So what we do is usually we can constrain the limitation of the packet size to a much smaller number. So it will be more compatible with all different networks, okay? And then for this IP protocol, we will have different versions. So the most popular one these days is the IPv4. So IP version 4, Internet Protocol version 4. So this is the most popular one that we're using. So it has 32-bit addresses. Okay, I think you are very familiar with this address, like some word dot some numbers dot some numbers some dot number and then dot numbers. Okay, it's 32-bit addresses. So with 32-bit addresses, it can provide you 4.3 billion addresses in total. So it sounds like a very big number, but actually it's not enough, right? Because like even the world population is like more than 6 billions, right? So of course, if one person have one devices, then these IP addresses will not be enough for everyone. Okay, that's why we need to have some newer version of the IP address. Sorry, of the IP protocol. So this is called IPv6. So this IPv6, it provides you 128-bit addresses. Okay, then it can give you much more number of addresses. 3.5 multiplied by 10 to the power of 38. Okay, so with this number, you'll be able to give the IP address for every single sand in the Earth. Okay, so it's much more than enough. Okay, so this IPv6, it resolved the major limitation of IPv4. Okay, that which is called that it has a very limited number of addresses it can provide. But in our course, okay, we are still using this, IPv4. And also, it's also still the most popular one that we're using now. Okay, maybe in the future, IPv6 will be more popular, but these days, IPv4 is more popular, okay? And then we're also going to talk about, DNS, domain name system. I think if you've set up your own Wi-Fi or some network things, you'll be familiar with this IPv4, IPv6, and DNS. At least I mean, at least you've seen these things, right? So DNS is just to translate the internet domain names to IP addresses. Okay, so it's translate from some human readable things to machine readable things. For example, the domain of this website, okay, of our university. So for a person, it will be easier to understand what is this website address, okay? But for a machine, it will not be able to understand. So we need to transfer it into some digits so that our computer will be able to understand what is this domain, okay? So this is called DNS. Okay, so we've talked a bit about the basic concept for network programming. And now let's talk about this most important thing, the transport layer, okay? We see the transmission protocol. So the first one we are going to talk about is TCP, which is called Transmission Control Protocol, TCP, okay? So TCP is a connection-oriented protocol. What means connection-oriented? Very easy. So it's like you can have a look at this picture here. So if you're drinking water, okay? If your mouse is connected to the bottle, you might drink slower, right? But it's connection oriented. So all the water will go into your mouth, okay? But if you drink in this way, in a UDP way, okay? So this UDP is another protocol that we are going to talk about later. Sometimes to be faster, right? If you drink in this way, but the more water will be dropped on the ground, okay? So it's not that reliable. So this is the difference. So the first one is called connection oriented. The second one is not connection oriented, okay? So it guaranteeing end-to-end delivery and sequencing, okay, for connection-oriented protocol. It guarantees end-to-end delivery. So all the data will be guaranteed go to its target address. Okay, that is called end-to-end delivery. And the sequence will also be guaranteed. Okay. So the data sequence will not be changed after the data is received. And then to guarantee these two things, we have three mechanisms in TCP. One is checksum, and then acknowledgement, and also retransmission. Okay? So checksum is used to check the data, sum of the data. Okay? So if the sum of the data is correct, then we suppose the data is correct. And then if the checksum is not corrected, it's not correct, then we just discard it and then retransmit the data again. Okay? And then after the receiver get the data, it need to give you a signal of acknowledgement, ACK, to confirm the receipt of data packets. Okay? And then if the sender does not receive a ACK signal from the receiver, then it will retransmit the data again. Okay? So this is called retransmission. So these three mechanisms guaranteeing the end-to-end delivery and the sequencing of the data. And also we have flow control. So it's just like when you're drinking the water. Your speed of giving water depends on the speed that you can drink, right? So this is called flow control. So we also have slow start algorithm. When you're drinking the water, you might drink slower at the beginning, and then when you feel better, you'll drink faster, right? So this is also similar. And we have full duplex transmission. What does it mean? It means that the receiver and the sender, they can send data simultaneously, okay? So it's just like when you are talking to a friend, okay? It's not like when someone's talking, you must stop. It's like everyone can talk anytime they like, okay? So this is called full duplex transmission. The receiver and the sender, they can send data in the same time, okay? They don't care about each other. This is called full duplex transmission. And then we will also know about this port number later, okay? We will have multiplexing based on port numbers. So we can do different tasks on different port numbers. This is called multiplexing. And then later we are going to introduce socket, a very important concept in this transport protocol, okay? Transmission control protocol or other transport protocol. Okay, then except TCP, we also have UDP. Okay, but UDP, the detail of the UDP we'll talk about in the next lecture. So today we are going to talk about a bit about UDP. Okay, so UDP is a connectionless protocol. So different with TCP, it is which is a connection-oriented protocol. UDP is a connectionless protocol. Okay, actually you can treat TCP and UDP as some couriers, as some delivery guys. Okay, you know, like when you order some delivery, some couriers, they will be very responsible, right? So they will give you your parcels by hand, and then it might get your signature as a feedback. Okay, so this is TCP. And in some other countries, the couriers might just go to your house and then throw your parcel in front of your house. They don't care about if the parcel is delivered or not, okay? They just go to your address and then throw the parcel in front of your door. Okay, so this is UDP. Okay, so UDP is a connectionless protocol. So it doesn't guarantee of deliver or order, okay? So although you order some parcels and the courier deliver the things, but this courier doesn't guarantee the delivery of order, okay? But it also have advantage, right? In this way, the transmission will be faster, okay? And then in UDP, we are going to do fragmentation. Okay, we need to break these UDP datagrams into small packets for transmission. This we'll talk about this in next lecture. Okay, and also like error prone, some other things we're going to talk about later. Okay, then here are some IP family of services or protocols. So some very basic services that provided by different servers, like the Echo server, Echo service. So this is a very simple service to check your connection of the server from your client to your server, okay? So what does it do? It just send back what you sent to him, okay? If you send hello, then it just send back hello. If you send how are you, then the server just send back how are you. So this echo service is just to check your connection to the server or to of your internet, okay? And then we also have some service called daytime service. We have some daytime server. So no matter what you send, it just give you the current date and time. Okay, once you connect to the server, it give you response of your current date and time. So this is daytime server. Okay, and some other services you can have a look. Okay. I'm not going to talk about details of all the services. Okay. There are 2 pages of services you can have a look. Then let's go ahead to the main point. The main concept of this lecture, okay? Socket. So this is a very important concept in TCP and UDP in data transmission, okay? So officially, it said like socket is an endpoint for two-way communication. Actually, it's not very easy to understand this sentence. At least I don't even understand by myself, okay? But I think we can understand in this way, okay? So server, oh, sorry. So socket, you can just regard this as a socket that you use, a socket like this. So you know that when you are going to charge your phone, you have like different socket from your phone, right? For example, even for iPhone, the old one is like this one, although they are all called Type-C, right? I forgot the exact name, okay? Let's suppose that we have 2 different sockets on your phone, right? And then you have a charger, you have a cable, okay? You have a plug, and you need to find some socket from the power supply, okay? So you know that for different countries, you might have different type of socket. So what's the main point here is that it will, for the server, it will have different ports, okay? Let's see that different port, it have different type of socket. So you need to choose the one you need, right? And also for a client, you also have different port, okay? You also need to choose the one that fit your phone. So what we do first is that the server will create a socket first. Okay, and then wait for connection. So when it creates a socket, it will give a port number and also the local address and the remote address. Okay, and after that, the client will also create a socket with the port number, the local address, and remote address. And then the client will send a request to the server for connection. Okay, then we will check if all the information is correct, if they are compatible. Okay, so it's like we need to check if the type of socket are the same. Okay, so how it checks? It just checks the local address, remote address, and also the port number. Okay. So after they check everything, the client will be connected to the server. So we say the socket is connected. So after the socket is connected, the client and server can start to communicate and send data over this connection. This is like the cable between these two sockets, right? Okay. So there are 4 steps. Server socket create, client request, socket connected, then send data. Okay, we have 4 steps here. So when we are doing programming, there will be some other socket vocabulary that you need to know. Okay, so firstly is the domain. Okay, domain is the transport protocol. In our case, usually there are several examples, but in our case, we will only use this one. Okay, usually we use this one. This is for IPv4. Okay, this is for IPv4. IPv4. Okay, and then for the type, we have sock string and sock datagram. So when we are using this socket stream, we refer to TCP. And if we choose socket datagram, then it's UDP. So the protocol is then defined by your domain and your type, okay? So usually we just keep it as 0. We don't clearly define what the protocol is. It follows the 2 things that you choose here. And host name, easy to understand, the identifier of the network interface. So it's like your IP address or the name of your computer. Okay, this is the host name. And port is that we just talked about, that we will have a lot of different ports for your server or client, right? So this is the port of the host or client to, so in the server part, it's the host, it's the port for the host to listen of the incoming request, okay? This is called a port. And also socket address. Socket address is the combination of the host name and the port number, okay? Like previously here, port number and socket address. The socket address include like port number and IP address, sorry. And so when we are doing coding, we'll have some socket module, and there's some, it provides you some general method to program your socket. Okay, so actually it's very easy to create a socket. We just use this line. Okay, this method. So this family type protocol file, that's is the things that we've talked in the previous slides. Okay, the file node, you can just ignore it. Okay, actually, we can ignore these two arguments. Okay, we just need to define this family and type. And then we have some other method to receive and send data. Okay. So here is for receive and send data. Receive and send data. This we will talk about later in the coding when we're talking about the programs. Okay. And after we finish the communication, we need to close the socket. We use this close method. And also there's a method to get the host name of the current device. Okay. You can just take a look. And here are some more important commands. Okay. More important method for server. So when you create a socket, you need to first bind the socket to address. So this address that we are going to bind to is called this socket address. Okay, that we've talked just here. Socket address. It's a tuple. It's a combination of host name and port number. Okay, so it's a tuple. Like this. Host name and port number. Okay, so here this address is the socket address. And then after we've bind your socket to the certain address, then we listen. We use the listen method. So this you can just understand is like a waiting command. Okay, so it enables the server to accept the connection. So after you create the socket is just there and keep waiting for connection from the client. Okay, that is called listen. And then after a client send a request to the server, then the socket will be able to accept the request, okay, or the connection. After the socket accept the connection, it will return something. It will return what? Firstly, it will return an object of connection. Also, it will return the address of your remote client. Okay, two things. It's also a tuple. Actually, this one is the client socket and then the client address. So you can understand it as after the server accepts the connection from your client, it returned some information of the client to itself. Okay. So then according to these two things, the server will be able to handle the request from the client. Okay. And then here are some other methods. This one, like create server, you don't need to, you can just ignore it. Okay. And the method for clients, we also have method for clients. Method for clients easier. Okay. Usually we just have a connect method. So this one is to send a request to the remote server. Okay. Also, you need to provide the host name of the server and the port number of the server that you want to connect. Okay. So I think you might not understand very well this part, but later when we're talking about these codings, you'll understand. Okay. Okay. So if we write this in a flowchart, it will be like this. Create socket. For server part, for the server part, you first create a socket and then bind the socket to your socket address. It's include your IP address and your port number. After that, you just use this listen method to wait for connections. Okay. And then after that, your client will also create a socket and then it will use this connect method to connect, to send a request to the server. So after the server receives the request, it will accept this request with this connect method, okay, to receive the request and accept this request. So it will start communication with the client. Okay, this is the communication part. So after all this part be done, okay, we will go to this next communication part. In this communication part, the client will send data to the server, and the server will send data as a response to the client. Okay, and after all the data has been transmitted, we will close the socket, both the client socket and also the server socket. Okay, CS here means client socket. Okay, it's the abbreviation of client socket. SS is represent for server socket. Okay. Okay, so this is the flowchart when we're doing programming for TCP server and the client. So as I've mentioned, from now on, usually we will have two programs. Okay, you need to do two programs for server and client. Okay, this is one program, one Python file. This is another Python file. Okay. So you will also run this server and client in two separate terminals. Okay, you cannot run them in the same terminal. So we'll run in two separate terminals, and then you use your client Python file to send some request to the server Python file. And then the server Python file will give some response to a client. Okay, so this is how our following labs will be. Okay. Okay, then let's have a 10 minutes break. We'll resume in at 10 o'clock. Okay. And then we're going talking about the programming part of TCP clients and servers. Mm. Okay, so let's go back to the slides. So now we are going to talk about the programming part as usual, okay? So firstly, we're going to talk about clients. We will have server and clients. So we will first talk about client, and the first thing is about daytime protocol, okay? So it's a daytime service, actually. I think it's more accurate to say it's a daytime service. So there are some service provided by the internet that it can give you the date and time when you send a request. Okay, so that is called a daytime service. And so daytime service can be accessed by both TCP and UDP. Okay, so we can see that we have some daytime server like in Hong Kong in this website. So for TCP protocol, once the client is connected to the daytime server, the server just sends its time to the client. Okay, and for UDP connection, the client sends a datagram to the server. And then the server returns another datagram with its time. So this we will talk in next lecture, okay? Today we are going to talk about TCP with daytime server and client, okay? So here is a typical program for daytime client. So at the beginning, we need to import some necessary libraries. So which is socket and system, okay? Then we need to give the socket address. So the socket address, as I said, it's a combination of the host address and the port number. Okay, let's see. We want to get some data from this server. Okay, this is the address of the server. And then the port, we define as 13. Then we just need to write a function to get daytime. In this function, we need to first create a socket. So this is a client socket. And in this client socket, we need to define the, this is the family, internet protocol family, right? Let me see. Oh yeah, the family of transport protocols, the domain, okay? Domain here. So usually we use this AFINET, okay? So this is represent for this IPv4. Okay, and then this is the method we use for the type of the connection. So for, as I said, for this sock string, the socket string is represent for TCP. TCP. Okay. So here it means we create a socket for IPv4 and TCP. Okay, then we just use this socket to connect to the server with the host address and the port number. Okay. After we establish the connection, we just receive the data from the server. So we use this receive function to receive a certain length of data. Okay, we need to define a length of data because we don't know how long the data will be. So we just define some large number here, like 1024. So this is the bytes, okay? This represents for bytes. UIT byte, okay? So it means at one time, we receive 1024 bytes. Okay, and then this function just return this one. Okay, so what this line represent for? So we got some data from bytes, right? From the server, which is in bytes. Then when you want to know what the data is, we need to decode the data from bytes to string. Okay, that's why we need to use this decode method. Okay, so human is not able to understand like the data in bytes, right? We only understand the data in string. Okay, so we decode the data. We need to decode the data and then strip the data. Okay, this is like an alternative. Okay, it's not necessary. When we're using strip, it just deletes some information. I mean, like some strings like empty spaces or end of lines. Okay, so it just give you the main string of the text that you receive. Okay, and then this two line is just to define the host and port. So actually, you can just ignore this part here and this part here. Okay, so usually we go to this conditional statement, we usually go to this else one. Okay, we have host and port. This host and port is defined here. Okay. Okay, then we just run this get datetime function in the main function, okay, to connect to the port, to connect to the server. And after we connect to a server, and if this server is existing, we'll get some datetime from this server. Okay, and here is the exact time we have. And this is like the number of date from some certain date, okay? So you don't need to care about this date, okay? This is like a date, like there is some special date they defined, okay? And then this number represents for how long it has been from that date, okay? It means it's like 60,000 days had been passed to that date, okay? But this is the exact time that it returned to you. Okay, so this is a datetime client. To get the time, the current time. Okay. Then let's talk a bit about this HTTP protocol. So this is like usually that we use for this website. Okay, and if we want to get some information from the website, we use the HTTP protocol. And we have two methods. One is get, one is post. Get is just like the word. It get some information, okay, from the website. So it means it retrieve web page from a web service, okay? And if we are using post, then we submit some data to the web server, okay? We are going to talk about more about HTTP protocols in the later lectures, okay? Maybe 2 weeks later, I think. So today we are just going to give some introduction, okay? And then for this HTTP request, we can use this method get that we just talked about, okay? And then this is a whole request. And what you need to take care here is that for all these HTTP requests, you need to have an extra empty line below your request, okay? So this is important. Every time you send a request to a web server, you need to have two empty, one empty line, okay? So it means two end of line symbol, okay? You see, this is the request. After the request, you need to have an extra empty line. Then the server will be able to recognize your request. Okay, if you don't put an empty line after your request, the server will not able to recognize your request. But this point we will mention many times later. Okay. So in your command, you will do like this. To get two empty, an extra empty line, you need to do like this. Okay, for example, you send a request. Then here is a symbol of end of line, okay, when you're using this enter button in your keyboard. And after that, you need to press your enter button again, okay? You need to press your enter button 2 times after you finish your request. Then the web server will be able to recognize the request you sent, okay? If you press the enter button only for 1 time here, the web server will not able to get your request, okay? So in your coding of a HTTP client, the most important thing here is that when you are sending data, okay, so other things are the same, that you create a socket, you connect to the server, and then you send data, okay? So when you are sending data, you will say that you have some symbols like this, okay? So we know that this /r represents for carriage return. This one represents for new line. And then carriage return, new line. So let me see if there is in the following slide. I think we've talked about this. Okay, so let's first talk about this one, end of line. So in these text-based networking protocols, we have something called end of line. Okay, this is an important concept. It's like your end of your command. Okay. So this end of line is denoted by 2 characters. Okay. It's 2 characters. One is carriage return. This one, carriage return. And then this is new line. Obviously the line feed. Okay, 2 characters. And the point here is that for different systems, the default end of line is different. So what is the default end of line of a device? It's your enter button, okay? Your enter button on your keyboard is a default end of line. So in a Windows computer, when you press the enter button in your keyboard, actually it is equivalent as that you input these 2 characters, which means when carriage return and when line feed. However, in your Mac OS, okay, in your MacBook, when you press the enter button, it's just one carriage return character, okay? It doesn't have a line feed character. Okay, and also in Linux, yeah, this is classic Mac OS. I think nowadays the Mac OS also follows Linux, I think. So actually, I'm not sure. I forgot. Okay. So for Linux, let's select in this way. For Linux, okay, when you press enter button, it will be just a line feed character. Okay. So you can see when you are sending command from different computers, different systems, if you're using the default one, the the enter button, if you press the enter button in your keyboard, then it will result in different command in different systems. Okay. So what we need to do is that we should avoid using this enter button. Okay. Instead, we do like this. We do like this. We write it manually. Okay. We write in the request manually of the end of line. Okay, so for a HTTP client, we need to have 2 end of line. As I said, why we need 2 end of line? Because we need to have an empty line. after the request, okay? That's why we need two end of lines. That's why I need two end of lines as we write here in the HTTP commands, okay? Character return, line feed, character return, line feed. So this is two end of line symbols or characters. So after we get this request, after we write this request, we encode it. So because this is a string, this is F string. Okay, if you still remember, this is F string. And then we need to encode this into bytes. Okay, again, bytes. Because computer can only understand data in bytes. Okay, so this is what we send, the data in bytes. Okay, after that, here we create a new data. Okay, this is just an initialization of a variable data into an empty bytes. And then we just receive the data from the server, use the receive function through the socket. Okay, and if the things we receive is not empty, then we just put the things we receive, the trunk, to the data the empty data we have. Okay, we just put the trunk into the data here. This is a defined data in bytes. So the data we received from the server is also in bytes. So we just concatenate the data we received to the original data we defined. And after we receive all the data, we just decode it into string. Okay, so we decode it into string. Okay. So this is the HTTP client. So here we just get some information from the web page. Okay. So here's an example of the things of the information from the website. Okay. Yeah, and here it talk about more about encode and decode. Because we know that, as I said, network communication transmit bytes, not string. Okay, computer can only understand bytes. Okay, so but we input string, right? So when we are inputting strings, we need to first encode a string into bytes. So usually we use this protocol, UTF-8. Okay, we use this UTF-8 protocol to encode the string into bytes. Okay, and then after we receive the data, we want to interpret to strings that we can understand. So we decode bytes to a string. Also use the UTF-8 protocol. Okay, but we use decode. When we send data, we use encode. When we receive data, we use decode. So here is an example. For example, there's a string here. Okay, and then if we encode this into a string to bytes, and we print the string and the bytes, it will be like this. The string will be something in this way. The bytes will be a B string like this one. Okay, so this is in bytes. And then if we decode the bytes here, we will transfer these bytes back to the string we have originally. Okay, so this is how this encode and decode work. Yeah, and then this end of line we've just talked about. When we're talking about things here, we've already talked about this end of line. Okay, so I'm not going to repeat again. Then let's talk about the server part. After we've got a client, we also need to program servers. Okay, So we still take an example of this daytime server. Previously, when we are programming this client, we are using some server or service from the internet. Where is it? Daytime client, okay? We are using some service from the internet, from the government. Okay, this is some government service. But now we want to create our own daytime server. How we do it? We just need to write some code like this. Okay, so firstly, again, we import the library that we need. Okay, and then it's the host address and your port number. Your own computer is the local host, okay? And then the port number, you can choose like 1300. And then for this daytime server, you need to create a socket again. Okay, this is a server socket. But the way is the same as how you created a client socket, okay? And what different with the client is that for the server part, if you still remember, we need to do like this. The flowchart here. We need to bind, listen, and then accept, okay? So there are three things: bind, listen, and accept. So accordingly, in the code, we need to do like this. We use this bind method to bind the socket that we just created to the host and the port that we list here. After we bind to the socket address, we just keep listening, waiting for the connection. Okay, and then you can have give some like instructions here that server start listening on some host address and some certain port. Okay, this is some information for you to understand what the server is running. And then after the server start listening, we're just using a while loop. Okay, so it will listen forever until there is a connection from the client. So once the client send a request, we will get this accept method. Okay, so this accept method will work until there is a request from the client. And once the connection is established to the client, the accept method will create two things. One is the client socket. Another is the client address. Okay. So with this client socket and client address, you are able to deal with the data from the client. Okay, and for this daytime server, there's actually no data from the client. You just need to send some response about the daytime back to the client. Okay, so it's like once the socket is established, the connection is established, we send the daytime. Okay, in a string. Okay, this is a string, and then we send it. We encode it and send it. Okay, that's it. We get the current time, encode the current time into bytes. So the current time was string, okay? But we encode it into bytes and then send the data to the socket, to the client socket. And then the client will receive the data by the receive method, okay? So if we look back to the client, when this server use this send all method, the client will able to receive data with this receive method. Okay. It means client will only receive data when their data sent from the server. Okay, so this is a whole procedure. Yeah, daytime server. Yeah, we're talking about it. Okay. Then let's talk about echo service. Okay, echo service. So echo service, as I said, just like from the previous part, echo service is just to check the connection from the client to the server. Okay, so the client will send something to the server, and the server will just give back what he received as a response. Okay, so for us echo server, it will be like this. Again, it will have two functions. Yeah, previously we only have one function, right? Yeah. For a daytime server, we have only one function in the server part. That's because we don't receive any data from this client. Okay, we just give some response of the current time back to the client when the connection is established. But for the echo server and the client will first send something to the echo server, and then the server will give back what it received. So here we need to have one more function to handle the things, the data from the client. Okay. So if we look at this echo server program, this part is the same, almost the same. Okay. Echo server part. So we create a socket, bind, listen, and then in this loop, we accept the connection, and then we handle the client. So we need to, the difference is that we need one more function to do this client handle. For example, here we have a function to handle the client. So what we do is that we just receive data from the client. So again, we have a socket, right? So with this client socket, when we connect to the client, as I said, when we connect to the client with this accept method, here, accept, we got two things. One is the socket, the client socket. One is the client address. Okay, so with this client socket and the client address, we can do some data manipulation in this way. So in this function, we get this client socket and client address. So we can write things or receive things with this socket, with this client socket from the server to the client, okay? So here we use this client socket to receive data. We receive some data from the client. Okay, still we define a certain length of the data, 1024, because we don't know about the length of the data that we will get. So we just put a large number here. And after we receive the data, we just send back the data, okay? So this function is very easy. Receive data and send back. And you will see that there's nothing about decoding or encoding, right? Previously, in the daytime server, we have like decode, encode, okay? But here, in this handle client function, we don't need to decode and encode anything because we just need to get the data and send back. We don't care about what the data is, okay? So I mean, in this function, human will not be interacted. So we don't need to decode the data into string, okay? So once we receive data in bytes, we just send back data in bytes. There's no extra steps between these two steps. Okay, after we send the data, the client will able to receive the data and then print it. And then the client will decode the data into string to see what it has received, okay? But in the server part, we don't need to do any encode and decode in this echo server. You will know more about these things in the lab, okay? Here is no, yeah. We have like echo, we'll talk about later. So let's first talk about this combination of multi-threading and network programming. Because usually we only have one server, okay, for some service. But in the same time, there will be a lot of clients, a lot of users, they want to access to this server. Okay, for example, when you are getting your grade, that you will access to the university website to check what your grade is, right? So you will have like a lot of students checking in the same time. But we only have one server maybe, okay? So then the internet will be very slow, right? So that's why we need to use this multi-threading, okay? So that means if we only have one thread in the server, when client is connected to the server will be stuck with the client, right? So it's just like when you are buying things. I mean, if you are ordering food, there's a queue, okay? So some people, they might order very fast, like in one minutes, okay? And some people, they might order, I mean, they might take a long time to order food, maybe 5 minutes. So if there's only one queue, then the other people will be blocked because the owner is dealing with one of the clients, right? It cannot deal with two different clients in the same time. That's why we need to have multi-threading, okay? So if we use a thread to interact with the client, then if there's a new client, okay, let's say we have a new client here, it wants to access to the service here again. So it just needs to give you another thread to you, okay? Then this thread will be in charge of this client. And the first thread will be in charge of the first client, okay? So then the service will not be blocked if you have two clients, okay? So that's why we need to use multi-threading. So how it works, actually very similar with the single one, okay? So we just connect to the server and then the server establish the connection. After the connection is established, it will start a thread for the client. And this thread will be communicate with the client, okay? So in this way, the thread is only in charge of communication. And this connection, socket connection, is still in charge by this main thread, okay? And the subthreads, no matter how many it has, it might have different threads, okay? 1, 2, 3, 4, 5, doesn't matter. It can deal with different clients. But these threads are only in charge of communication, not establish of connection, okay? Then let's go ahead to the code of multi-threaded echo server. We still use this echo server as example. So here is the server part. For the handle client function, is exactly the same. Okay, we don't need to change anything. what we need to change is just this server part. Okay, this server function. So at the beginning, it's the same. As I said, we create socket, bind, listen. Okay, so when we accept this connection, we need to use multi-thread executor. Okay, this is what we learned from the previous lecture, right? This is create a pool of multi-thread executor. Okay, so in this way, it will assign different thread for different clients. And in this thread, it will get the request from the client and then submit the handle client function to the thread to deal with the data from the client. Okay, so this is very similar with the previous code we were using. Okay, and then there's no client. Okay, still we don't have clients. Okay, so this is a traditional way that how we do this programming. Multi-threaded echo server with socket library and this multi-thread library. Thread pool executor library. Actually, there are some easier library that we can use. Okay, for example, this for TCP we can use threading TCP server. This is another library offer you easier programming methods. Okay, so let's see how it works. So we import this threading TCP server library. Then the client handler is still the same. Nothing changed. Then the echo server will be much easier. So we just need to use this library, threading TCP server. Okay, then we give the socket address here and then the client handler function. So this method will create socket and multi-thread executor together, okay, in one line. After you create this server, it will be a multi-threading server, okay? Then you just need to use this server.serverForever as listening. So this server.serverForever is equivalent as what we used before, which is listening. Okay, listen, the listen method. It means it creates the socket and bind to the socket address in this threading TCP server method already, okay? So it's like 3 in all, or in one, sorry, all in one method, okay? Yeah, so we replace the code by one line. And then the things are all the same, okay? The function are all the same. We just simplify the code. Time is it? Okay, I think it's very close to the end. Let's be faster. We only have one thing left, okay? So then we are going to talk about this line-oriented data. Because sometimes some protocol demands the server to handle data line by line, okay? For example, you send something that you want to access to a server, okay? You send that your username, your user Alice, okay? And then the server said that username is okay, need password. Then you send password. Then the server told you that you've logged in. Okay, this is a line-oriented data. So the client send one line, and then the server send back one line. This is called line-oriented. So previously, we are using this receive method. Okay, if you still remember, we use this receive method and we need to define the length of the data we receive. We use a very large number of 1025 or 24. Okay, so because we don't know the exact length of the data we receive. So is there a better way? Of course, there is. So we discard this receive method, okay? And instead, we use a makefile method. So in this makefile method, it will create a file-like object. And then this file-like object, it will provide you a method of read line to read a single line from your file, okay? From your object, from your socket. But the problem is like sometimes when you're using this receive method, you might read not only one line, okay? You might read half of the line or sometimes even 2 lines. So this causes some problems. That's why we need to use this makefile method to create a file-like object. And the code, what we need to change in the code. The only difference like this. In this socket, client socket, in the client socket, when we get this connection, okay, we need to use this makefile method to create the connection. Okay, and this makefile method, we need to define 2 things. Okay, this is the mode. RW means write and read and write, okay? Because you need to, both server and client need to write or read from the socket. So this socket, we defined it as read and write mode, okay? And then the encoding method, as we said, we are going to use this UTF-8, keep the same. So in this loop, we just need to use this read line method to read a line from the socket. Okay, and then we just need to strip the line. Okay, we just delete the end of line symbol, the character, and then write back the things we want and flash it. Flash means to send the data directly. Okay, so this is what we need to do for the server part. And for the client part, it's even easier. Okay, we just need to use this makefile method again in this socket, and then we just directly write something in this file object, which is this socket. So we define this socket into a file object and write things into the socket and then send it. Okay, and then we read a response with this read line function to read the data from the server. Okay, so we strip the empty lines and then print the response from the server. So this is how we do with this line-oriented data. Okay, so that's it. The URL library, we are going to talk about it when we meet the application. Okay, we are not going to talk about today. Okay, so then it's the end of class. And see you later or tomorrow, okay, for the lab.